Can you solve this advanced exponential equation? When you look at the board, it kind of look intricate, but it's actually very, very simple. Now, we're going to be using the UniFiX strategy to answer this question, in fact, to approach this question. What is the UniFiX strategy? First of all, we identify the forms of the variable of x, then we try to transform the different form of the variable so as to make the variables have the exact same form. Now, when we achieve that, to make this question easier to solve. Now, when we look at this question, first of all, let's identify the forms of the variable x. Look at x here now is not a power, doesn't have any log. Compared to this, the x here is a power and it also has a logarithm. So now what we're going to do is to try and make these two forms of the variable of x have the same form. We try to transform them and make them equivalent. Now what we are going to do is to express s as a power and also a log. So how do we do that? We use one of the fundamental laws of logarithm, which says that a raised to the power log b base a. When you have the same numbers like this, the base cancels this and we are left with what? B. That's one of the fundamental laws of logarithm. We use that here also. So we can rewrite x as 10 raised to the power log x. We have, instead of x, we have 10 raised to the power log x log 4 plus 4 raised to the power log x equals 32. Now I haven't done anything strange because in logarithm, whenever you see log without a base like this, it means naturally the base is 10. Okay, it means naturally the base is 10. So just like this law here, log 10 cancels 10 and we have x. So can you see it's the same law, just a little bit of tweak. So the 2 power multiplies law of indices, then we'll have 10 raised to the power log x times log 4 plus 4 raised to the power log x equals 32. Now we are getting very close. You know the UniFiX, don't forget, the variables must have the same form. We have to unify the variable and fix the equation. Now the variables here are now very, very much alike. Log x here and log x here, but there's just one more problem. What is that problem? This log x here has a multiplier of log 4 or a coefficient of log 4. Why this does not have a coefficient of log 4? We have to introduce log 4 to the power so as to unify them. We must, due to UniFiX, please, we must. Then how do we do that? We're still going to use that same law of logarithm, okay? We can express 4 as 10 raised to the power log 4 will give us 4 because 10 cancels log, gives us what? 4. Let's write 4 as that. So we have 10 raised to the power log x times log 4 plus, instead of 4 now, we're going to be having 10 raised to the power log 4, then multiplied by log x, which is equals to 32. Still the same thing because 10 log 4, log cancels 10, it gives us 4. We haven't done anything wrong. Now we can see that we are now there, okay? So let's rewrite this as 10 log 4 times log x plus 10 log 4 times log x. We did not do anything strange here. We just wanted to look exactly the same. So we have log 4 log x, log 4 log x. We have now finally unified the variable of x. They now look exactly the same. What is next is now to simplify, which is the last step. Now you look at these two, they are exactly the same. 10 raised to the power this, 10 raised to the power this. So when we add them together, it will give us 2 times 10 raised to the power log 4 log x equals 32. Because they are exactly the same. It's just like saying y plus y will give us 2y. They're exactly the same. So now we divide both sides by 2. When we divide both sides by 2, we have 10 to the power of log 4 times log x equals 2. Now 32 divided by 2 is going to give us what? 16. So we have what? 16. Now what is the next thing to do? We now have an exponential equation like this. Now what do you do in exponential equations? We try to eradicate the power. We don't like power. It makes our question look complex. We don't like power. So what do we do here now is we use that same law also to express 16 as the power of log 10. So we have 10 to the power of log 4 log x equals to 10 raised to the power log 16. Because 10 cancels log to give us 16. We haven't done anything wrong. Now we can now say 10 cancels what? 10. So we're left with log 4 times log x equals log 16. Yes, Now we have two constants because log 4 will give us a number, log 16 will give us a number. We have two constants. So let's divide both sides by log 4 so as to isolate log x. So then have log x will be equals to log 16 all over log 4. Are you following? Now we can simplify this using the law of logarithm because 16, we can express 16 as 4 raised to the power 2. Okay. Now we have log x equals log 4 raised to the power 2 all over log 4. And according to the law of logarithm, this power comes behind as a multiplier. Okay, so we're going to have log x equals 2 log 4 all over log 4. So log 4 cancels log 4. So we're left with log x equals 2. Can you see? It's very, very simple. Now I'm left with a logarithm equation. And when we have a logarithm equation, we don't like this log. We like try to eliminate this log by expressing this equation in an index form. And according to the law of indices, the base raised to the power this will give us x. And the base of this logarithm is what? 10. So I'm going to have 10 raised to the power 2 equals what? X. So when we flip this, we have x equals 10 raised to the power 2 is what? 100. 10 equals 100. Our final answer, you can see, is very, 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 very simple. When you input the value of 100 into this equation, you are going to get 32. Very simple. Now, don't forget to subscribe, like, and share this video so as to see more enlightening content like this. Thank you very much for watching.